In example 7, they have done something that is a very common thing done on the AP exam. They have given me a graph, not of the function f, but of f prime. I don't know what the function is, but they've given me a graph of it, and this is enough information for me now that I know the relationship between f prime, and f double prime. They want me to find where the function f is concave up and where it is concave down and where it has points of inflection. So they've given me a graph of f prime, and they want me to talk about concavity and points of inflection. That means that we're going to be talking about the second derivative. Now, the second derivative, as it pertains to this graph, is nothing more than the slopes of the tangent lines. And so let's do a couple of things. Let's find out, first of all, what the critical values are for f double prime based on this graph. So to do that, I want to determine where does it look like the tangent line has a slope of 0. So here I would say f double prime of x is equal to 0, and that seems to correspond to the point 3. Down here it looks like it's horizontal right about there, and I mean, you know, looks like -1 to me. So again, f double prime of x is equal to 0. So I have critical values for f double prime. And now I can begin to talk about the slopes of my f prime curve, which are the values of f double prime. Let's make a sign chart. All right, so I have sketched a sign chart directly underneath the graph, and so we're just going to carry these critical values straight down. Here is -1, here is 3, and now I want to start thinking about what my f double prime, what my slopes are doing. So to the left of -1, the slope of f prime is negative. So I'm going to put a minus sign right here. Now, where else is it negative? You know, it's also negative to the right of 3. Notice that the slope is negative on those two intervals. So I'm going to put a minus sign over here. Now notice that the slopes are positive between -1 and 3. So we'll put a plus right here. Okay, now what does this mean in terms of f of x? Well, okay, so if f double prime of x is negative, that means that f of x is concave down. So I'll put a concave down over here. If f double prime of x is positive, that means that f of x is concave up. So now I've got all the information to write a conclusion. Notice that if the concavity is changing from concave down to concave up, doesn't that mean that -1 is a point of inflection? And notice that if I'm going from concave up to concave down, 3 is a point of inflection. So now, let's see what we can say. F of x has points of inflection at x equals -1 and at x equals 3. F of x is concave up on the interval from -1 to 3. F of x is concave down on the intervals -∞ to -1 union to infinity.